Hello everyone. Today we're focusing on Cambridge IGCSE Mathematics, topic of number, subtopic speed, distance and time. And to start off, we're looking at the formula that connects speed, distance and time, which is speed is equal to distance over time. So for example, if we want to find out if a car is traveling 400 meters in 20 seconds, how fast it's going. So it's simply a matter of divide the distance, which is 400, by the time, which is 20 seconds. And voila, we find out the answer, which is our speed. And you can see the notation. You can either write meters per second with the slash, or you can choose to put it as a power to the power of -1. Moving on, so if we want, we can always rearrange the formula. So we can swap the speed and time. And when we do that, we get time is equal to distance divided by speed. So for example, a question where I want to find 216 kilometers, speed is 72. So I can divide 216 by 72, which gives me the time as 3 hours. And how do I know it's hours? Because the speed was given to me as kilometers per hour. And again, another rearrangement, which is distance equals time times speed. So for example, for a question where 9 kilometers per hour for 2 hours, and we want to find out the distance, well, we just have to multiply the two, and we know that it's kilometers again because it's kilometers per hour that the speed is given in. So 18 kilometers is the solution there. And that brings us to the end of today's short lesson on speed, distance, and time. All right, and we're going to do a few questions just to finish off. Jez leaves the house at 10:40 and reaches the bus stop in 14 minutes. So identify the time she reaches the bus stop. So that's 14 minutes after 10:40, which is 10:54. Rose drives 110 miles to her workplace. Her journey takes 1.5 hours. Work out her average speed. And you can see that the speed is given in miles per hour. So we need to basically use our formula, which is speed is equal to distance divided by time. So distance here is 110. Time is 1.5. So I simply need to put 110 divided by 1.5, which is going to give me 73.3 miles per hour. Moving on, Andrew walks at a speed of 4 kilometers per hour. He had to travel 3 kilometers to school. What time should he leave if he has to be there by 3 p.m.? So basically the distance that he has to go is 3 kilometers, and the speed that he's walking is this. So we know that time is equal to distance divided by speed. So distance divided by speed means that it's going to take him 0.75 of an hour, right? Which is if you look at that in terms of minutes, that's basically 45 minutes that takes the person. So if he wants to be there by 3 p.m., he has to leave the house at least 45 minutes earlier. So hence he needs to be out of the house by 2:15 p.m. And the next one, in a city in Russia, there were 7 million cars, correct to the nearest million. The average distance traveled by each car in one day was 7.5 kilometers, correct to first decimal place. Find the upper bound for the total distance traveled by all the cars in one day. Okay, so basically 7 million is rounded to the nearest million, right? And if we're looking at the upper bound of that, that's basically 7.5 million. And the same way, 7.5 kilometers is being rounded to one decimal place. So the highest there could have been 7.55 kilometers. And we're looking at the total distance traveled. So basically that is going to be 7.55 times 7.5 million basically, and that gives us a solution of 625,000, which is basically the last option here. And that brings us to the end of today's short little snip of speed, distance, and time.